Hello everybody. Today we're going to be doing the AP Calculus BC free response questions for 2019 in order to prepare for the AP test coming up. So we'll just work our way through these. And here we go. So first, question one. A graphing calculator is required for these questions. So fish enter a lake at a rate modeled by the function e, given by e of t equals 20 plus 15 sine of pi t over 6. Fish leave the lake at a rate modeled by the function L, given by L of t equals 4 plus 2 to the 0.1 t squared. So E of t is the rate at which fish enter the lake, and L of t is the rate at which fish leave the lake. So both E of t and L of t are measured in fish per hour, and t is measured in hours since midnight. Okay, so with A, how many fish enter the lake over the 5-hour period from midnight to 5 a.m.? Give your answer the nearest whole number. So in order to do this, we can, since it's asking specifically about how many enter the lake, we don't need to worry about L, because that's just referring to how many fish leave the lake. So we can focus on just E of t. And since the E of t is the rate at which fish enter the lake, we can take the integral of E of t from 5 to 0 in order to find the difference in fish that enter the lake from 5 to 0. And so we can do that work. And we can see with E of t, which equals 20 plus 15 sine of pi t over 6 and if we take the integral of this function from 5 to 0, then that will give us the total number of fish in the lake, or the difference between time equals 5 and time equals 0. And this is what we'd use our graphing calculator for, and we take the integral of this kind of gross looking function, and it comes out to be 101.71, and as I said, to round to the nearest whole number, our answer is 102 fish. Alright, and now I will delete this, and we'll move on to part B. So what is the average number of fish that leave the lake per hour over the 5-hour period from midnight to 5 a.m.? Once again, this is the same idea. This time we're just going to be doing it with L of t instead of E of t. And so we can say integral from 0 to 5 of L of t, which is 4 plus 2 to the 0.1 t squared dt, and this comes out to be 30.195, which is a total number of fish that left the lake. And actually, I'm now realizing this question, it's important to see that it's asking what is the average number of fish that leave the lake per hour. So the difference between this question and this one is this question is asking how many total fish enter the lake over that period, and this one's asking the average number of fish per hour. So the only difference is once after we do this integral, which we get 30.195, in order to find the average amount of fish leaving per hour, we divide by the number of hours. So since it was from time equals 0 to 5, that's 5 hours, and we divide by 5, and then we get 6.059 fish per hour. That's how many fish left the lake per hour. And that is part B. Moving on to part C. At what time t for 0 is less than or equal to t is less than or equal to 8 is the greatest number of fish in the lake? So in order to find, we know in order to find the maximums of a function, what we can do is take the derivative of the function and set that equal to 0. Because we know that maximums and minimums of a function have to be their derivative has to be 0. For example, I'll draw a little graph here. So here is the x squared graph. In order to find where there's a max or minimum, we can take the derivative of x squared, which is 2x. I'll draw the little axes actually. Whoa. It's hard to be precise. There we go. We can take the derivative of x squared, which gives us 2x. And when this equals 0, we know that there's a max, or it's possible for there to be a max or a min. If it doesn't equal 0, then it can't be a max or a min. So we solve this and we have x equals 0, which is at this point right here. And as you can see from the graph, that one is a minimum. In order to figure that out, you can either, there's multiple ways to do it, but I think the easiest example for this one is you can take the derivative of this function, and if it is positive at that point, then that means it's concave up, which would mean it's a minimum, which this graph is. And if it was negative at that point, then it would be concave down, which would make it a maximum. So that's kind of a little bit of a review of how to find the maximums of a function, which we can use in order to find here the greatest number of fish in the lake. We're trying to find the maximum between this interval. So in order to do that, we need to find, okay, so what is the function that maps the number of fish? Well, the functions that we are given, we have the amount of fish, the rate at which fish enter the lake, and the rate at which fish leave the lake, which these two functions are actually just the derivative of the number of total number of fish entering and leaving the lake. Like for example, for A, in order to find the total number of fish entering the lake over that period, all we did was take the integral of this. So that means in order to have the total number of fish in the lake at any given time, we take this function and we take the integral of it, and that would give us the total number of fish entering the lake. And this function, L of t, we take the integral of that, and that would give us the total number of fish leaving the lake. So we take the integral of E of t minus the integral of L of t, and that would be our total number of fish in the lake overall. So that is our function. And now we don't actually need to evaluate that, because as I was talking about before, in order to find the maximum, we're going to be taking the derivative of that anyways, which means it's going to cancel out the integrals we do at the start. So we end up just taking E of t minus L of t and setting that equal to 0. Sorry about that. What we're going to be doing is E of t minus L of t equals 0. And keep in mind the interval between 0 and 8. So it has to fall within that interval. So I will refrain from fully writing this out, as it will take a lot of unnecessary time. We have both equations here anyways. So it would just be 20 plus 15 sine of pi t over 6 minus, and remember to distribute the negative because it's going to be applying to both of these terms. So minus 4 minus 2 to the 0.1 t squared, and that equals 0. And once again, this problem can use, we're supposed to be using a graphing calculator, and we can solve it using that, and we end up getting t equals 6.204. And this is the only maximum within the interval, and it is the maximum amount of fish in the lake during this interval. That is question C. Then part D. Is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? So in order to answer this one, and it says explain your reasoning. So this one we can kind of use logic. So it's asking, is the rate of change in the number of fish in the lake increasing or decreasing? Well, the rate of change, first of all, we need to understand what is the rate of change of the number of fish. Well, the rate of change in the number of fish in the lake, we have E of t, which is the rate of change of the fish entering the lake, and then L of t, which is the rate of the fish leaving the lake. So like we did before, if we subtract E of t minus L of t, then that will tell us the rate of change in the number of fish in the lake. Since we know from part C that we had a maximum at t equals 6.2, that means that let's say we have a graph of the rate of change, and let's say it looks something like this, a little a little curve, and then the maximum point is 6.2. Well, we know this is a maximum because we found that out in part C, which means, and we know 0 has to be over here and 8 has to be over here. Well, this means that 5 somewhere, or 5, wherever 5 is, must be increasing. Because in order to get to the maximum rate at 6.2, we know 6.2 has to be greater than 5, and we also know that 6.2 is the only maximum within this interval, meaning a function kind of like this is not possible, because that would give us two maximums. Because of that, we know it has to look like this, and therefore 5 must fall somewhere around here and must be increasing. The rate of change at this point must be increasing in order to get to 6.2. And that completes question 1. So moving on to question 2. These we can also use graphing calculator for. So let S be the region bounded by the graph of the polar curve r of theta equals 3 root theta sine of theta squared. 4 0 is less than or equal to theta is less than or equal to root pi, as shown in the figure above. So A, first we'll find the area of S. So in order to find the area of polar curves, there needs to be, it's different than finding the area of regular graphs, so on like an xy plane versus r theta plane. So in an xy plane you can just take the integral, but in r theta plane it's different. And the way I like to remember it is, imagine you have an r theta plane, right? And let's say your graph is just a circle, right? Well, the area of a circle we know is pi r squared, right? And in this case, let's just arbitrarily set r equal to 1 just for simplicity. So the area of the circle is pi r squared. Well, in any other in any other polar equation, r might be variable, like as we saw in our graph. R equals 3 root theta sine of theta squared, and it's not just a simple circle as we can see in this picture. So the way we are going to deal with that is, in order to take, let's say, a partial area of the circle, like let's say instead of the full circle, we just want to take the area of this quadrant. Well, you can just take the full area of the circle, which is pi r squared, and then multiply by the angle theta, which is the total angle right here of the circle it encompasses. So like this quadrant right here is taking up 90 degrees, or pi over 2 of the circle. So you can multiply by theta over 2 pi. So the way I like to think about it is theta over 2 pi is just the percentage of the circle you're taking the area of, and then multiplying by the total area, which makes sense. And when you evaluate this, you get the actual area is just r squared theta over 2, because the pi's cancel. Well, as I believe I started to say earlier, r is variable, which means it's not going to be like an actual circle. It could be a random shape. So in order to deal with that, we use an integral. And we're going to use the integral of r squared d theta. So as theta is changing, we know that r is going to be changing, which is why we take the integral from there, and that is going to give us our area. So this becomes, or it doesn't equal, but is leading us to our equation for the area of a polar function, which is going to be 1/2. I just took the constant out of the integral of r squared d theta. And this is our equation for the area of polar functions. So now we're going to apply that to this problem. It's going to be 1/2 times the integral from root pi, because that is our endpoint to 0. As shown in the question, it says for 0 is less than or equal to theta is less than or equal to root pi. So from 0 to root pi, sorry for the messy handwriting, of 3 root theta sine of theta squared. And don't forget, this is equal to r, and it's r squared d theta. And so when we evaluate this integral, we end up with 9 pi over 8. We can use the graphing calculator for this, and that is the answer of the area. It's part A. Okay, so then we have part B. What is the average distance from the origin to a point on the polar curve for the same interval? So the distance formula is a little bit different. So we can kind of use logic to try to figure out how we're going to approach this problem, what math we have to do to figure this out. So it's asking for the average distance from the origin to the point on the polar curve. So we know, actually, for any given point, the distance from the origin is just going to be its r value, right? So for example, if I have theta equals 0, then r of 0, the radius at that point is going to evaluate to 0, because we'll end up with sine of 0, and that is 0. So we know that r is 0 at that point. So in order to find the average distance from the origin to a point on the polar curve, we need to find, you can kind of think about it as adding all of every single infinitesimally small change in theta, what all radiuses, all r values for every single possible theta in this interval, adding them all together and then dividing by the interval. The interval will give us the average distance from the origin, right? If we add up all possible r values and then divide by the number of r values we have, that'll give us the average r value, which is the average distance to the origin. Well, obviously we can't just keep plugging in numbers for theta. In order to do that kind of infinite sum, we use the integral. So for this problem, we just take the integral of this equation from root theta to 0 and divide by, did I say root theta? Sorry, from root pi to 0, and we divide by root pi. Oops, my apologies. So it becomes the integral from root pi to 0 of 3 root theta of sine theta squared d theta. And we take this integral and we divide it all by root pi. And this is going to give us our average r value, which is the average distance from the origin, which comes out to be 1.58. And once again, we use the graphing calculator for this. And there you go, that's our final answer. Moving on to part C. There is a line to the origin with positive slope m that divides the region S into 2 regions with equal areas. Write but do not solve an equation involving one or more integrals whose solution gives a value of m. Okay, so Um, First of all, when it's talking about this positive slope m, that's referring to, and it's gonna be a line, a straight line, like this. We have our graph, and then this is gonna be like a straight line. So m is referring to the rise over run of this line, the slope of the line, right? But that's with y and x values. So we have to keep in mind when we're solving for m is, well, let me rephrase. We're gonna have a polar graph, and somehow we need to make m a number we can get. The rise over run, which is talking about y, like change in y over the change in x values, but we have a polar graph, right? So we don't have y and x, we have r and theta. So in order to do this, we actually have, we can convert. So this is our theta, and then any point on the line will have some kind of distance r. But this is the theta we're worried about. We need to try to find a way to get from theta to y over x. Well, actually, if you make a triangle like this, you can notice that the opposite side to this angle theta is y. It's going to be the y value of this point right here. And then the adjacent side is going to be the x value. So if we do the tangent of theta, that's actually going to equal y over x, which is equal to the slope, which this is important to know. So tangent of theta equals m. We're going to need that for later when we're trying to solve for m. So there's a line through the origin whose positive slope m divides the region S into two regions with equal areas. So we actually found the area in part A, which means what we can do is set up an integral to where we use this identity here to find the endpoint theta. We're going to find this theta that it splits the region S into two. So here's what I mean by that. What we're going to do is imagine we have a theta. So I'm going to write the equation or the expression for area, and we're going to say the integral from some value theta, we don't know yet, to 0 of our function, which is 3 root theta times sine of theta squared, and this all squared d theta, equals, we have from part A, the total area is 9 pi over 8, so equals 9 pi over 16. So we want some value theta to where that works. And luckily here, we can convert theta into m. So actually, if we change this, if we do the inverse tangent of both sides, we'll get theta equals the inverse tangent of m, which means that we can just substitute this theta for inverse tangent of m. And now this question was just asking for an expression from which we can solve for m, and we can from this expression. So this is actually our final answer. This is the integral from which we can find the value m. All right. Oops. That's annoying. I can't get rid of this. Sorry. All right. Moving on. Part D. For k is greater than 0, let a of k be the area of the portion of region S that is also inside the circle R equals k cosine theta. Find the limit as k approaches infinity of a of k. So, the first thing that's important to know is when we take this limit as k approaches infinity with this equation R equals k cosine theta. Well, the graph of R of of cosine theta, r equals cosine theta, that polar graph looks like this. It's a circle and it's got radius 1 and it's only in these quadrants like this. And as you add coefficients to the front, for example, r equals 2 cosine theta, all that happens is this circle becomes bigger. So then the radius becomes twice as big. And as you keep doing that, the radius gets bigger and bigger. So you can imagine as this value, this coefficient, which is k, approaches infinity, we're just going to get a big circle. I know it's a bad looking circle, but imagine an infinitely large circle that encompasses this first quadrant and this fourth quadrant. Which means all we're doing basically as value k approaches infinity is taking the area of S, but only in these two quadrants. That's all we're going to care about. So quadrants 2 and 3 are left out. So what that means, we're going to use that information to solve this question. It's asking for k is greater than 0, let f k be the area of the portion of region S that is also inside the circle, r equals k cosine theta. Find limit as k approaches infinity. So all that means is we're going to find the area of S, but only in quadrants 1 and 4. Luckily, none of it goes into quadrant 4, so we only have to worry about quadrant 1, which is only the integral from 0 to pi over 2. So that's the first quadrant. So that means we're just going to do the area equation, and it's going to be not from root pi this time, but from pi over, sorry about that, from pi over 2 to 0 of 3 root theta sine of theta squared. All this squared d theta. And when you evaluate this, it comes out to about 3.32. And that is our answer. All right, and that's question 2 done. So moving on to question C. So now these are the question 3, sorry. These are the no calculator questions. So we will no longer be using a calculator. So the continuous function f is defined on the closed interval -6 is less than or equal to x is less than or equal to 5. The figure above shows a portion of the graph f consisting of 2 line segments and a quarter of a circle centered at the point 5,3. It is noted the point 3 minus root 5 is on the graph of f. So we have if the integral of 5 or of -6 to 5 of f of x dx equals 7, find the value of the integral of -6 to -2 of f of x dx. All right, so the integral from -6 to 5 is going to be we don't know this part of the equation. We only know from -2 to 5, right? So it's asking, we know that this entire integral from 5 to -6 somewhere over here is 7. And we're trying to find, well, what is the integral from -6 to 2? So up to this point, the part we don't know. So we know that -6 to 5 is the total integral. So actually, we have the integral from -6 to 5 of f of x dx. Now this is actually going to equal the integral of -6 to -2 of fx dx, which is the thing we're trying to find, plus the integral from 5 to from -2 to 5. So this is the unknown part, which we're going to have to try to find, and this is the known part. Well, luckily, we know this is given. This equals 7. And we can solve for this. So we're going to subtract that integral from -2 to 5. And that is going to be the answer we're looking for. Oops. This is the answer we're looking for. Right? So in order to do that, all we have to do is find out what this equals. And I'm actually going to keep all this work, or I'm going to keep this bottom work so that we keep this in mind. We just have to find this integral from -2 to 5. So we can't use a calculator, so what we have to do is just calculate the integral by hand, which is just going to be we can use geometry for this and just take the area underneath the curve, right? So the best way to do this, I think, is to start doing math and cancel out things that can cancel out. So for example, here we have this half triangle, it's a full triangle, but half of a unit. So the area of this is 1/2. But then when we go from -2 to -1, but then when we go from -1 to 0, this is -1/2. So these two parts just cancel out. Now here, this triangle, it's this little section is 1/2 the distance, and it's 1/2 a unit, and then this is a full unit. So the area of the triangle is going to be 1/2 times 1 over 2, base times height over 2 for the triangle, which is going to give us an area of -1/4. So keep that in mind, -1/4. But then we have this triangle, whose now its base is 1.5, and its height is 3. So 1.5 times 3 is equal to 4.5 divided by 2 is 2.25. But then, so we have this is 2.25, this is -0.25. So it's just going to be equal to 2. And then this section. Well, here, in order to find this, we know this is a quarter circle. So we're going to take the area of this full section right here, which is going to be just 9, 3 times 3, minus the area of the circle. Well, we know its radius is 3, so it's going to be pi r squared, so 9 pi over 4, because it's only a quarter of a circle. So it's going to be 9 minus 9 pi over 4, and so now I'll start writing this down. So this integral is going to equal 2 from all the triangles in the beginning, plus, and then 9 minus 9 pi over 4. So we can find 7 minus all of this is going to equal the answer we're looking for, which comes out to be 9 pi over 4 minus 4. And that is our final answer for that, for the integral from -6 to -2. All right, moving on. So B, evaluate the integral from 3 to 5 of 2f prime of x plus 4 dx. So, the integral of this, if we do the indefinite integral of that equation, then it's just going to end up, I'll write out, integral from 3 to 5 of 2 f prime of x plus 4 is going to equal, well, the integral is going to cancel out with that f prime plus then 4x out, and we're going to be plugging in 5 and 3. And when we do that, well, f of x, well, f of 5 is easy. We see that's 0. F of 3 is more difficult. That's why they gave us this point. We know f of 3 is going to be 3 minus root 5. So that's why they gave us that. So we're going to end up, once we evaluate this, where you do 2f of 5 plus 4 times 5 minus 2f of 3 minus 4 times 3. This is going to evaluate to 2 plus 2 root 5 once you do all the math, and that is the answer for that one. All right, moving on, part C. The function g is given by g of x equals the integral from -2 to x f of t dt. Find the absolute maximum value of g on the interval -2 is less than or equal to x is less than or equal to 5. Justify your answer. Okay, so to find the maximum, I talked about it earlier. we're going to be taking the derivative of g and setting it equal to 0. Well, luckily, when we take this derivative, it's just going to cancel out that integral, which means that it's just going to end up being f of x. And we're going to find f of x when that equals 0. That is a possible maximum. So when f of x equals 0, that's a possibility. We're going to have to check all of these. So in order to do that, we can just look at, here we go, this is f of x. So there's a f of x equals 0 at -1, 1/2, and 5. And then also keep in mind that since the interval is from -2 to 5, we have to check both of those points as well, because it's possible that they could be a max, as is the start of an interval. So we're going to check -2, -1, 0.5, and 5. And all we have to do to check that is plug them in to g of x and find which is the maximum value of those. And that's a lot of excess work. We already talked about doing the integral in part A, so I'm just going to skip that step, and you can practice it on your own. We find that the maximum value is actually g of 5, which is going to end up being 11 minus 9 pi over 4. So that is the maximum value. All right. Then D, find the limit as x approaches 1 of 10 to the x minus 3 f prime of x over f of x minus arctan x. Okay. Well, if we plug in 1, let's see. Let's write this out. Limit as x approaches 1 of 10 to the x, gotta look back, 10 to the x minus 3 f prime of x, f prime of x over f of x minus arctan x. Okay. So when we evaluate this, 10 to the x is, or 10 to the 1 is 10 minus 3 f prime of x. Well, f prime of 1 here is just going to be the slope of this line, which we can see the whole thing. It goes up 4 over 2. So it's got a slope of 2. So it's 2, which is 2 times 3 is 6, 10 minus 6 over f of 1 is 1 minus an arctangent of x is pi over 4, which means we get 4 over 1 minus pi over 4 is our answer. There we go. All right, moving on to question number 4. A cylindrical barrel with diameter 2 feet collects rainwater. The water drains out through a valve at the bottom of the barrel. The rate of change of height of the water barrel with respect to time is modeled by dh over dt equals -1/10 root h. The volume V of a cylinder with radius r and height h equals V equals pi r squared h. Okay, so find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. So in order to do this, what we're looking for is dV over dt, which is the rate of change of the volume of the water. So dV over dt is what we're looking for. So in order to solve this, we've been given dH over dt. If you remember, dH over dt is right here, -1/10 root h. Okay. From here, we know that V equals pi r squared h, which was given to us as well. So what we can do is take the derivative of both sides with respect to time, and we'd get dv over dt equals pi r squared dh over dt. And we know dh over dt, so we'll plug that in for there, and we can solve this equation. dv over dt equals pi r squared times negative 1/10 root h. Because this question, it gives us h is 4, and r is 1, because the diameter is 2, which would give us dv over dt is pi times r squared, r is 1, so times 1, times root 8, h is 4, times 2, so times negative 2/10, which is just going to be negative pi over 5, which is our answer. All right. Whoa, what did I just do? Whoa. Sorry about that. Okay. Moving on, part B. When the height of the water is 3 feet, there's a rate of change of the height of water with respect to time increasing or decreasing. Well, when we have dh over dt equals negative 1/10 root h. I don't think I need to show work for this one. Is the rate of change of the height of the water increasing or decreasing? So this is the rate of change of the height of the water. So we want to know if it's increasing or decreasing. Actually, I will show work. So we have dh over dt equals negative 1/10 root h. In order to find whether or not this is increasing or decreasing, we can just do the derivative of this, which is d squared over h over dt squared. When we do the derivative, it's going to be negative 1/10 times, well, this is h to the 1/2, so times 1/2 times 1/2, and then it's going to be 1/2 minus 1 is h to the negative 1/2, so it's going to be times 1 over root h. So negative 1/20th root h. Well, when h is 3, it's going to be negative 1 over 20 root 3, which is a negative number, which means it's decreasing because it's negative. There we go. So decreasing. Part C. At time t equals 0, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. Alright, so dh over dt, once again, equals negative 1/10 root h. So separation of variables, what we're going to do is separate dh and dt. So we're going to get the h's on both sides, or on the same side. So I'm going to just divide root h from both sides, and we're going to multiply the dt equals negative dt over 10, like this. And then we're going to take the integral of both sides. Well, the integral of 1 over root h is going to be 2 root h, because when you take the derivative of this, you're going to do h to the 1/2 is going to go h to the negative 1/2, which would put it on the bottom, times 1/2, which will cancel out with the 2. So it's 2 root h equals, and then there's negative t over 10. And we know at h equals 5, t equals 0. So 2 sorry. Oh, I'm gonna solve for h, actually, sorry. So we'll divide by 2. It's going to be root h equals negative t over 20. And then square both sides. H equals t squared over 400. And we know when t equals 0, h equals 5. So that means the constant is plus 5. And this is our answer. Sorry, I should note, when we do this integral, we have this plus c constant, which is where all this is coming in. So you divide by 2 and you get negative 2 over 20 plus c over 2. Since it's an arbitrary constant, we can just leave it as c. Then when we square it, once again, it's an arbitrary constant. So we can just leave it as c. And we end up with h equals t squared over 400 plus 5. There we go. And then finally, I believe, question 5. Consider the family of functions f of x equals, it's hard to see, but it's 1 over x squared minus 2x plus k. So find the value of k for k is greater than 0, so the slope of the line tangent to the graph of f at x equals 0 equals 6. So we know f of x equals 1 over, and it was, x squared minus 2x plus k. And we know f prime of 0, I believe, equals 6. Was that what it was? Yes. Prime of 0 equals 6. So what we're going to do is, even though we don't know what k is, we're going to just take the derivative of this like we do. And we know k is a constant. So the derivative of this, it's like a u substitution. The derivative of 1 over x is, equal to x to the negative 1. So the derivative of this is just going to be negative 1 times x to the negative 2, right? So that's what we're going to do here. I'll write it over here. It's just going to be negative 1 times 1 over x squared minus 2x plus k squared. And then just a chain rule times the derivative of this. K is a constant, it's going to cancel, so it's just times 2x minus 2. And we know this is going to equal 6 when x equals 0. So the good thing about when x equals 0 is all these terms cancel. So we're going to just have negative 1 over k squared times negative 2. So it's just going to be 2 over k squared equals 6. So that means k is going to equal root of 1/3, which is our answer. All right. B, for k equals negative 8, find the value of the integral from 0 to 1 of f of x dx. So f of x, we know k equals 8 is going to be 1 over x squared minus 2x plus 8. We can factor out this denominator. So it's going to be 1 over x minus 4 times x plus 2. And we're going to take the integral of this from 0 to 1. Okay, so in order to take the integral of this, what we're going to do is do the separation. We're going to separate this fraction. So in order to do this, we have 1 over x minus 4 times x plus 2 equals, and some value a, which we don't know, over x minus 4 plus some value b. Well, that's horrible. Sorry. Some value b over x plus 2. And so we're going to just multiply by x minus 4 times x plus 2 on both sides just to cancel this out. And then this is going to cancel, and it's going to be a times x plus 2. And this is going to cancel, and it's going to be b times x plus 4. Or sorry, x minus 4. Right. So a times x plus 2 plus b times x minus 4 is going to equal 1. So the way I like to do these problems is 1 equals, I'm going to distribute first, ax plus 2a plus bx plus, minus 4b. Well, there's no x's on this side, meaning ax plus bx has to equal to 0. Or ax plus a plus b has to equal 0. Because these x's have to cancel out. Which means a equals negative b. And we can then substitute that in. And we're going to know 1 equals 2a minus 4b. But a equals negative b. So it's going to be just plus 4a. So a equals 1/6. And b equals negative 1/6. Which means that this is going to become the integral from 0 to 1 of 1 over 6. A was over x minus 4. So times 6x minus 4. And then minus, because it's b is negative 1/6 times x plus 2. And now we can do the integral of this. We're able to do that. And we're going to get, it's going to be ln of x minus 4 over 6 minus ln of x minus 2 over 6. And we're going to plug in 1 and 0. And it's going to be like that. 0. And we know how to do the integral, so I'm just going to skip having to write down all that work. And once you evaluate it, it's going to come out to negative ln of 2 over 6. That's our final answer. All right. And the last question. For k equals 1, find the value of integral from 0 to 2 of f of x dx to show that it diverges. So it's going to be now f of x equals 1 over x squared minus 2x plus 1, which is actually, we can factor this to just 1 over x minus 1 squared. Now the problem when we do the integral from 0 to 2 is that there's a vertical asymptote at x equals 1. So in order to deal with this, we're going to do two separate integrals. One from 0 to 1 from the negative side of 1 over x minus 1 squared. And then plus 1 from the positive side to 2. 1 over x minus 1 squared. So in order to prove that this is divergent, either one of these can be divergent. If one of them is convergent, the other one's divergent, it's still divergent. So let's start with just this first one. When we do this integral, it evaluates to, this is the same as 1 over x minus 1 to the negative, or sorry, not 1 over. It's just equal to x minus 1 to the negative 2, which when we take the integral, we're doing like the reverse power rule. So the integral of this is just going to be negative x minus 1 to the negative 1, which we know when we take the derivative of this, the negatives will cancel, and it's just, this will go to negative 2. So this is the integral. And now we're going to go from x, which this is equal to negative 1 over x minus 1. So you can see that better. And we're going to plug in 1 and 0. And we'll notice that when we 1 from the negative side, it's still approaching 0. So it's going to be infinity, which means it's divergent, which means that the whole thing is divergent. And that's the final answer. So I hope you were able to learn a little bit from this AP review, and hopefully you'll be prepared for the AP test. I wish you guys luck, and thank you for watching.